Again, either raw is continuous, right? But for simple to raw, but actually either I must raw like this to find. Okay. Right? But either raw like this is so slow. So that's why I just think that I just capture it here. I said, right. So how to find the value Z? Actually, because remember here array, right? Here array of 30 degrees, right? We're talking about array. So the very simple how to. You have to follow from here to here, you compare with the value and you find the nearest value, right? That's all, okay? That is the idea. Do you know what I mean? Because it decreases.
Yeah.
So that's why you can, for example, here, you follow from 0 to 55, you get the value CZ, you compare with it, okay? You get the smallest, right? The nearest value. That's the idea. Or you can do like that. Okay, you can do like that. I define the function g equal to cz, okay, of z subtract for what? For w. Okay, w here, right? And then the z0 equal to what? Mean of what? Of g, right? I count here gz. Mean of gz along z. Okay, that is mathematics, right? But actually, how to program? You take array, you subtract for on, and then you set the minimum value. Okay? Minimum value, okay? And that is the way to transform. Again, that is the way to transform two distribution. And you apply here for just histogram function, put in the net in some other lecture for example in machine learning. When you want to transform two distribution, you remember this figure. Okay? For example, KL reversion function, you remember in machine learning, you just transform this distribution into this distribution. That's all. The idea you put compute C cumulative, and you make here. Okay, that is I tell you about how to do. So again, I give you API because I don't have the time with 30 hours here, right? So why that is I sign. You have to try to process. And here I give you the run how to do that is formula on, and then maybe in final exam I give you look like you have to follow step here for some step. Right? Paper here. And you okay? And then you can see how they implement the equalizer. How they implement the histogram. You are able to implement this right now. Right? So I covered the first topic in 4%. Now we go to the next. Before we go to the next, there are some Before we go to the next here, there are some. I want to clear some question, clarify some question. Any question? You. Histogram equalization. Histogram equalization and matching is the same topic. The difference is just the target distribution. For histogram equalizer, given the image, and I ask you to make the image more contrast. The meaning of more contrast means that the intensity distributes uniformly look like here. Can you see? Okay, but here uniform is no, but the theory is uniform perfectly. But practical when you compute for each image, it might be the hit. You can see the distribution is more from 0 to 55. You can see the change for hair, the distance. distribute more equally compared to the input. So again, what is the effect? I give you the image to that line. Can you see? Right now, no, right? But after equalize, you get this effect. It's more easier for classify, recognize, and so on, right? So that's why you have to do the regression. How to do again? You just transform episode. You just transform episode inside here. Okay? Episode inside here. Okay? By to match with histogram uniform.
What is the applications of histogram matching?
Histogram matching. Histogram matching is sometimes in application, especially for medical even. Especially for medical. Because for medical even, they give you the uniformly, maybe the week will come back. So that's why sometimes you have to design the output distribution. Okay? You want to emphasize, okay, almost around this zone, right? You draw this curve. You control it. It's very simple.
The output here and graph template. That's you.
Okay. Sure. He's asking the question to look like related to application. Here we study theory, right? But what is the question? How to specify this? In medical image processing, there are some, okay, ABI, sorry, user interface, okay, user interface graphics, user interface tool, right? You add to the wrong curve here by some amount, right? Okay, you can move the amount here. When you move here, you see the output image. If you satisfy, okay, you stop. If you don't try to move, there are some user interface. But sometimes, for example here, you don't get it, you get it. Okay? And then you compute the histogram here from this. But actually, in order to apply histogram matching, you have to decide the output histogram. Any question more? Any question more? Now, we go to the section is important. A local question. Local question. Local means not the area for the computer event. Here is so. Like S0 and Y0 visual and L0 and Y0 that is visual. What does mean local? Local means that the area around the visual. Okay, that is window. Maybe 1 by 1, 3 by 3, 5 by 5, and so on. 1 by 1 means that this is so. This is 3 by 3 means that the area of 3 by 3, the B and the center. Okay, so 3 by 3, the center. Means that how many pixels inside? 9 pixels. Right? And the visual at center, there are 8 visuals around it, we call neighbor. Here we call neighbor or center. Okay? Neighbor. Neighbor với đất họ sống. Inside window. Okay, that is what I mean local. And local very important. In for local, what does mean local portion? It means that you have here input image, here output image. Here S, here Y, here is F, FY, here is 3FY, and also F0, also Y0, here Y0, here S0. Okay. Here I define the window. Here window here I define the name right here we call W. W contains how many pixels? If 3 by 3. The window if 3 by 3 means that contains 9 pixels inside. If 5 by 5, 25 pixels inside. That is I define by W. So what do you mean local operation? Means that you define for each G S0, Y0 equal to some function f, j, so function we call T, okay, or W. Remember, W is the window contain, okay, on the pixel in this area. Okay. So you can see what I mean local operation for each pixel. Okay, how to do? For each pixel in output, for each output, right? You assign value by transform corresponding area in the input. What do I mean corresponding? Tương ứng. Okay. If that for each pixel here, you assign value by perform transformation on the corresponding area, the function. And function T, that is there are two linear or non-linear. I think function may be non-linear. Let's talk about linear first. When about linear, one law very important we have convolution. In Vietnamese, we call tích chập. Okay, that is very well known operation in machine learning right now, in deep learning, right? Okay. And what do we mean convolution? Okay, we have slide. We call slide too long. Okay, how do you know? I tell you on every here. And linear, that is convolution, okay? And how to define convolution here? Let's talk about we define in order to explain the convolution. And first time it becomes hard. So that's why I explain correlation first. Okay, correlation. But actually two are very flexible, very similar. Okay. So now let's talk about. I give you an example of convolution by with window 3 by 2. How to? I give you about example. Now I assume window equal to sine symmetry assumption. Window 3 by 3. So you have 9 pixels inside. I call pixel inside we call. Okay, you can see the pixel 3 by 3. I call P1, P2, P3, so on. So you have P1, P2. Okay, that is pixel. Pixel value inside of window. Okay. Now what do I mean? What do I mean? The value G0 G of S0 and Y0 equal to W1 multiply P1. Okay. No. Then maybe plus B. So what do I mean? B0 you know already. B0 or BI, P not B. PI, that is pixel value. Pixel value. Well, what do I mean? W1, W2 and W9 3. W1, W2 we call weight. Okay. Weight bias of the filter. Or filter. So that is just the value, just actually just three value. So you can see around it. Is okay? Can I write it? Where I define vector W equal to what? W1, W2, W9, and I define vector P equal to P1, P2. So I write very short form. Okay? And this equation, you can see now here vector, here is the value, we not reward scalar. So this function is we call linear function, right? When that is linear function, that represents the hyperplane, right? So that's why linear. So that's why we call convolution is linear. Convolution. Okay. So you can see convolution. You have the window. You have the window we call W1, W2 window of 9, 3 by 3. W1, W2, so on, right? You move the window for each pixel here on the image. Okay? When for each pixel here, you compute by this formula. If it not on of output image, on of output pixel, share or yield the same value of WG. Okay? Share or yield the same. For the this pixel, you have this formula. This pixel, you also have this formula. You yield this area, but the way and the bias is the same. Is it okay? That is convolution or convolution. Convolution and correlation is very similar. Okay, just different methods only. So okay, instead of follow step by step in slide, I tell you about convolution only. Is it clear? Is it clear? How fast to compute convolution? How fast is it? How fast is it? How fast is it? And now you just deal, right? You just deal it, right? I don't want you to deal or to element, okay, because it's too hard for you. question is how far? Thinking about how far. For each pixel in output, you have to do like to compute by the formula here, but you pick up the region of pixel, right? Different region of pixel, but you share the same W. How to calculate? How fast? It depends on size of image and size of what? Size of window also, right? Because size of window become large. Before here you can see 9 multiplication, and how many? Also 9 addition. Because addition, right? But that is the new element by how you think about conversion. That's it. But there are another way to compute very fast. Another way very fast because using fast Fourier transform. So that's why you can see how conversion working and correlation working. Again, shall I tell you a lot about correlation and correlation, including mathematics? But I don't think so. I don't think you should remember this and you apply this for even. You should think how to remember convolution how you work, correlation how you work. Okay, mathematics is just one way, another way. For the whole convolution. What are they? For the ball, look at the ball. Okay, that is. Look at the ball. Here is convolution kernel. You can see in convolution of correlation, you have the window of wave in back. You can see you also have wave W1, W2, right? So right, and also one when you compare B. Okay. So the matrix W we call kernel. Okay. Or we call hàm nhân in Vietnamese. Or we call window. Okay. But actually kernel, window, template. That is just thinking about it. That is window. I represent here. It contains way inside and one way out. Okay. Wait. And image here. How correlation working? You can see you have the window. You play here. Left. You align this left the top, right? That's very 3 by 3. So you can see here you have 3 by 3 with 9 value of W. Here you occupy here also 9 value of P. Right? You only have 9 pair. W1, V1, W2, V2. You compute by that formula. You compute by that and you assign the value here. Is it okay? You assign one. Okay? Then what? Next. You move next one pixel on left from left to right to one pixel, or many pixels depend on you. That the number you select from left to right we call stride, okay, or step stride. Okay, and you have also you share the way. So here the same contain 9 way W, and you occupy different area. So you have different value of B. So you also compute by that formula. You get value you assign to this. You continue to do like that, right? And when you end with that line, right or line, right? You stop, you get a pixel like this. Here. And you go back to the beginning. You shift from top to down 1 pixel or 2 pixels depend on you, depend on stride. You compute it, and you get pixel. You compute it by that formula. You assign that pixel. and you similar to this around here, and you compute on. That is idea of what? Of correlation or convolution. How it works? Remember how it works, okay? Just sliding window, move window, right? Slide. Or round image, multiply addition over there, you assign. Okay. So you can see detail in the here, right? So what is different between correlation and convolution? About the formula. Here, what? The kernel, okay? You have to rotate the kernel. What does mean rotate the kernel? Actually, you flip on web X and Y. Rotate equal to flip X plus flip what? Flip Y. Or flip Y and then flip Y. Okay, you can try. For example, here is 1 1. Now I tell you about 1 1, 1 2. That is kernel, input kernel. So if you apply convolution in theory, I emphasize convolution in theory, you have to flip X and flip Y. Flip X, what are here? Flip S, and then flip Y, what are you flip? So you flip S and then you flip Y, or you flip Y first and then flip the same. You have the same result of the computation. What do we rotate one more? You can see here, right here. Now you put the over there, right here, W11, W12, W13. So row top become button. From left to right, and now right to left. Now left, W21, W22, W23. W31. So that is input and output. Mean not. If that is a kernel, we call W. So row 100 degree of W equal to. Amen. So again, convolution in theory, then you have to input kernel, you have to rotate, and then you perform correlation. What is correlation? You apply, you use the kernel, you apply, right? You slide, you apply, right? You multiply and fill over there. So you have convolution. For correlation, here we call convolution, we call tích chập infinity. Here we call tương quan infinity, right? So for correlation, you need not to rotate. You apply directly, and then you compute, you slide, right? That's all. We call correlation. The difference between correlation and convolution is just rotation of kernel. Okay? And actually, for example, in Kira or in Bangkok, Even the ABI conversion, both actually they compute correlation, not conversion. Okay, you can decide to do that. So again, correlation conversion theory, you have to rotate kernel. And you can see why not. Because even in deep learning Kirach method, you can see it perform correlation instead of conversion. Okay? Because the difference between two here is just rotate or not rotate. What? The kernel. Okay? For conversion it has to rotate. And for mathematics, yeah. But the question is why you have two concepts like that? Because you can see, because next chapter you study about fast Fourier transform. As I told you before, in order to compute convolution, right? By what you think, right? It's too slow. There is one method called fast Fourier transform. In fast Fourier transform, you have to it corresponding to the convolution without this formula. It without in mathematics, in order to compute fast Fourier transform, okay, it corresponding to the result of convolution, not convolution. So that's why for mathematics you have to rotate kernel. Okay, now we go detail about convolution. Now how it works, right? And here. I assume that the kernel is between contain low value V. I assume that no VR right now because if VR is just 1V also. After rotate 100 you have it for convolution. You apply on the whole image. Now image is just 4v4. You can see you group the image tree here, you group it. You flatten. And kernel and in formula, in general, I just K float 1 that is so the kernel right now is 3 by 3. The image is smaller. It's smaller. Smaller by what? By 2 pixels. 2 pixels. On left, on right, and top 2. On top and bottom also. So okay, you can see for before you separate from one on left, from one on right, one top, one down, on each. Sorry, for the confusion.
What if stripe is involved? Will the formula change? If we add stripe into that?
Yeah, no, I will do that. Battery is right. What do I mean the battery? Concept of battery, what is battery? Although you can see here what I mean battery first picture. The image right now is 4x4. You in hand one left, one right, one top, one down, right? So you have like that. In that 4x4 now you create 6%. What is value here? Missing value. 0 or maybe any. You don't care, right? But by default it's 0, right? And too much 0, so I don't want to write. So after the body. And this body we call half body. Half body why? Because our kernel is 3. Our kernel is 3. You take into the division for 2, you get 1. Okay? So we're half body. Okay? In Kirach, that is equal to body equal to value. Okay? In Kirach, when body equal to value, without half body. In my talk, you have to specify body equal to 1. Okay? Exactly. So you can put in any, but they in different, there are some method only. Just half body. like this, or full bedding. Or same bedding. Here in Kirat Valley, it means no bedding. Here we can't say. If bedding in Kirat, okay, I will tell you Kirat Valley what. Same. What I mean? Because why same? Same means up bedding. Why because like that? Because okay, by the end you can see the output here is 4 before. Okay. 4 before, output also 4 before. So that's why if you want the output image is the same as input image, the output feature map is equal to the sign the same as input feature map. You have to use half that, right? Or same if you not. Okay, same not the same sign. Okay, that's all. And do the same. Do the same. Okay, do the same video only. Okay. No bedding, half bedding, right? Now full bedding also. But actually full body actually almost not. But okay. What I mean full body? When you move the kernel far on left, but have one occupied on first column, like we call you image that head. Now you bet K1, K1 to 3 minutes, you bet 2 on left. 2 on right, 2 on top, 2. Because 2 bedding. Now non-units, not the by default the strike equal to 1. Now what I mean strike equal to 2. Strike equal to 2, you can see now for example full. Now you put for it. The next you move to left, okay, 1. This you move to left, to right, 1. No, that is the unit strike. Now strike equal to 2 means 1, 2. You move the right, you move to the next position. Means the right on this side. You can see. Yeah, okay. So first, here the center of kernel. Next center kernel between the 2 right now. And similar. Okay. And after that you move down. Okay, you have it. And here also relation between kernel side, input side, bedding, and also the kernel side output. Can you implement and how get this formula? You have slide, then go to home, and then let's try how. Do not accept it, but let's think about how. Similar to river, side from here to here is I float with to B, right? Pet P minute on left and on right now, so 2P. Right? So subtract for K side. But you have to divide by what? By strike. Remember integer division. Integer division. And you subtract 1 plus 1 plus 1. Okay, I tell you before. For example, 3 by 3. So you reserve here for the last. So equals to 1 here, and then you just compute the side from here on here. So that formula.
What is S sub 2? What is S sub 2?
That's to P1, P2 means that in this pattern, you call P1 on this side, you call P2.
What is S sub 2?
Subtract to what?
S 2.
S2.
Try.
Try on this. The unison try on this. Unison. And that is that. Net for multi-channel. For example, by default, the yield is grayscale. But if the input image is RGB, then you can see by default. You have kernel also triggered. Right? By default, also kernel also triggered. Here I just random value of kernel. Now you can see. So you have image. I told you image, but in deep learning that it might be intermediate feature map, right? Intermediate feature map. If not regional right now, and also can also regional. And then how to look? The kernel you have to rotate 100 degree, 180 degree. Rotate for each flank RGB. Right? After that, you plot it. You have 999 plus 27 values of kernel. Or we call weight, right? Now how to look? Okay, you compute input output side right now 2v2. How to look? Here image, RGB channel. Digital kernel you occupy. You crop the image. You crop. You take button. You have 29, 27. And you multiply there, you take dot. You get volume here. Okay? Very clear? It's similar to one channel, right? Similar to one channel. You treat flatten for it. Next, you move to next. Also, strike by default right now here, strike only one to right. You crop, flatten. Dot product, you get it. Next, also similar, right? Similar. You get that is all of the convolution. That is multi-channel. If not, if the input image or input the data in multi-channel, you do nothing. But the multi-channel, then important kernel also multi-channel by default here. But they are for only one channel. Only one channel. Now here is notation. Input feature map or image. Kernel share form. Here output just one channel. So what happens is multi-filter without multi-channel without the data multi-channel. Multi-filter without that you have perform multi-convolution parameter. Here, only. So as in that, for example, input image. Kernel 1 or convolution 1, you get that channel. Next, 2, 3, and K. Now you have K filter. You get K feature map. You can count together. You get the output feature map. Here. Right? So you can see that is the 4-1 convolution. Right? For color image, number of rows we call H, net height. C right now equal to 3 right now, right? S W C. Channel R. For one image, C equal to 3 right now. For an element, you have n C. So you get how many dimensions in array here? 4 dimensions. So we call tension of array of 4 dimensions. So the output also, the one element you also return here. So that is output also n. Now we S star, Y star, and C star. So n would be n, but S star depend on stripe, depend on bedding, right? Where also channel depend on number of channel, number of filter. Here is equal to number of filter. Okay, number of filter. So that is I then on about the conclusion in reasoning. Now, I give you for some demonstration. Portable, you have Kira, conclusion. This layer. The area here, so okay, I assume that you know how to use, so that's why I have to import and so on. You have to import, right? You have to import, for example, from Kira, CF Kira, layer import conclusion. Okay? So now here number of filter means not the number of channel output. Okay? Kernel size, for example, is defined by 3 by 3, 1 by 1, 5 by 5, depends on what is odd number. Do you know why odd number? It has a center, right? It has corresponding to output to input with basic. Let's try by 1 to 1, you know, valid equal to valid, that is no valid. And next here for data format equal to none, that is the last, channel last, no last. Relation not right now, not right now. Activation okay, not right now. GVR equal to true, means not GVR. It means not this formula. Here. I remove only. I clear only here. For the VB, right? Okay. GVR equal to true. And kernel initialize means that related to the how to generate the kernel. Because before deepening, you have to learn it. The way where you have to learn it. But in order to learn, you have to initialize it. Means not random variable, right? So how to initialize by this? So I think that is almost you know only. Almost the parameter important you know only. For bytecode. So, bytecode, you can see you also have similar. In bytecode, in channel means that you have to specify input channel. In Kira, you don't need to specify. But in Kira, in BTOP, you have to specify. Right? You have to play the input in number of channel input. Number of channel output corresponds to number of filter. Okay? Number of channel output corresponds to number of channels. Kernel size, stripe might be kernel size, you can use triple. Okay, you can use triple or integer. If you integer, it is the same for all dimensions. Here also triple or integer value equal to 0. Okay, relation look like here. Yeah, here value equal to 2. Okay, so on. So on more important to know. And in by top, you also have some function. For example, functional here. You can call a function. You pass input, you find ways. When you satisfy that is function. There are three dots with top and also NumPy. Can you see it? I can just identify some SI away, but they had both and they did also. In you're also able to use scientific library convolution 2D to perform the convolution. But actually, what is different between the Scilab, Scilab, PyTorch, and Keras? Right? Because the library Scilab PLE designed convolution traditional convolution methods, right? So that's why it's support only grayscale. It also single computer, single filter, just one filter. So it's limited. But actually, for the old one, okay, before library, okay, you have to use it. But right now, I encourage you to use PyTorch and Keras. But you have to compare this and Keras and PyTorch, and you can see Keras and PyTorch. The yield concept of convolution, but actually you don't rotate kernel. Actually inside correlation. And you have to do some example for me. For the way you can see layer the convolution. Okay, take one kernel, try but then give up you have it. And you by top. In that, you have to compare all of them. But you the same way, whatever. And you have to do that, right? What are you? Okay. Now right to here. Okay, look at the ball. Correlation of convolution. They call the local because they transform the process from local area surrounding the center. To get a value, you assign to the corresponding region. The formula of constant is linear. Okay, linear. We call it linear equation. That's why we call linear transform. And for when not in linear transform, what is the effect of convolution? You can do like that. Average, shifting, Gaussian, and detection, so on. Here it is. So you have concept of the portable. You have from here you have some concept. Portable mean function, or portable in Ipcv, or maybe in all the library you find with the portable off filtering or average filtering or mean filter, right? So I did linear. So when looking at linear, what defines the name of that? Linear is convolution, right? So what defines the name of function? Portable mean average, mean or average filter. For example, in Ipcv you have average filter. So why they call average?
The weight.
Why? Because linear means not convolution. Convolution is just how to specify convolution, just specify way bias. And by default, cái bias equal to 0 for traditional image. Bias equal to 0. By default, bias equal by default to. But for example, XKC sin left, right? By default, you get bias equal to 0, right? So why did you the average? You know why? What? Look at the ball. Please come here and then listen to me, okay, sharing. You save a lot of time when you come back home. Why they call average or mean field function? Because output equal to WT, right? P, right? So how to what? Wherever because for example here, the pixel here, that equal to the average of pixel inside of the local area. We call average and easy. Okay? So when average, when we're talking about average, what is the way of average? What is the way of average? B equal to 0. And what is the W? Hmm? 1 over the
Size.
the size, meaning that the number of way, right? Inside, right? So 1 for example 9 by 9. The frequency that is 1 over 9, right? Why? Because you sum and then you divide by 9, that is average. So all way the same. Now, so then when talking, you can see when you study about convolution and then now you come back, you can see convolution can be used in the average or mean function or mean average filter as well. Mean filter or filter, right? Sometimes filter equal to, okay, what now you can see what is the effect of mean filter. It makes the image become blurred, right? That effect. Gaussian function. Now, you just sample of the grid time into 3 by 3. The set like that you have Gauss function. For example, here 3 by 3, here 5 by 5. They sample for you only. You load it, you give. And what I mean here weight, here weight. That it becomes weight. So you can see here the mean, and that is Gaussian filter. That is effect. And now, what happens if you shift? Okay, again, my question. Example. If you apply kernel here with conclusion, right? What is the output image? Look like. Then look like. What it look like? Here is center, right? What it look like?
Bring down.
Here the input image. Right? That is input. What the output look like?
Bring the input toward the bottom left corner.
What look like? Good about thinner.
Right.
If you fail with the questioning exam, what happens? Okay? Auto. That is output. What is it? If not, you can see the pixel here become the pixel here, right? Okay, and so what? For the here, pixel here, oh, sorry, pixel here become pixel here. Pixel around here. And okay, let us draw it. Is it the event on this direction? How many pixels? 2 pixels. One other. Because here kernel for convolution you have to rotate 100 degree. If that one become what? Become here. Okay? One become here. And 0 right? So if that 0 multiplied on equal to 0, 1 equal to this. So it copies this on this, you assign to this center. And this. How do you think? Okay, very simple to do. Just you apply convolution this to the image, you see the output and the input. You see the effect, right? That's the side. Okay, yeah,
Teacher.
input and output.
Teacher. From previous slides about definition of linear filtering, so linear filtering is applying H using convolution and correlation. So there's no information about whether it is used, whether it used convolution or correlation. So we cannot. Yeah.
Okay.
So the direction is not.
Actually the convolution, the slide you got the linear it just apply convolution or correlation. Okay, because they are just very different between the rotation. But when talking about traditional definition, the filter is by default that is convolution.
So that is by default.
By default, that convolution.
So in design as well.
Sure.
Okay.
Okay, sure. But again, just you can see now that is just the very minor difference. Again, the relation between convolution and correlation is just rotate the kernel. But unlucky, traditional, for example, scilab, right? Okay, for example, you import scilab dot convolution 2D, then that is traditional. So that's why it applies convolution mean that the way it rotates the kernel. But now modern library look like Kirat method, right? Because they learn the kernel. Okay, so that's why they just use correlation. Okay, so you have to use three library and then you compare, you see very clearly, right? Okay, that is it, right? And now, commutative point of view, you perform use swap like this because it transform, right? Commutative operation. Also associated correlation, convolution equal, that important. But important in the past, but now modern it might be not, because why? Now you try to eliminate convolution by using GPU cards, deep learning. So that's why it has a modern technique for compute. But actually, you are here, you can optimize your model. For example, if you know the model in deep learning, you have the model of inception. In deep learning, later you learn about inception. For example, inception V5 from V5 on, right? V5 plus. It's used bit property to optimize the computation. Okay, so it's faster. It's the same result, it's faster. It's linear also, right? For example, what I mean? If you apply this to the whole image, it's slow compared to you apply this to image, and then you get intermediate image. You apply this to intermediate, you get the same result. But when you decompose like that, it becomes faster. Number of multiplication is fast. That is the idea of the association. Here this slide is for a long time, so that includes the model also the both filtering mean that the on of the kernel on the way equal to 1. So there are some homework you have to read for me about integrating concept into one. Concept that is very interesting. But let's talk about for array and similar for 2D. If you quite often, many times, you want to take the sum of window different size, right? Maybe 2, maybe 3, okay, different location, right? It's fast and possible. The probably sometimes you want, sometimes not, sometimes quite often, right? Without the very frequent, right? You compute the sum of a string of value or a singular value. Different on different position. For example, this time just sum of 2 value. This time just sum of 4 value. Next time just 2 value. Next time just 2 value. For example, like that, right? How to perform fast? How to perform fast? Just linear. No, not linear. Sorry. Just maximum be 4 operation. Linear first. That is linear. That is 4. How to right? That is integral. If you have to compute the integral, you have the cumulative value, and then you take one here, sum of 2 value into this one, you take this value, check for this value, and then you get it. Okay? That is idea. 2D, okay, also 2D. Here important, so that's why I ask you to evaluate at home. This, okay? So I want to close the lecture tonight. They are 1 or 2 minutes sharing your ideas. Question? Is it clear? I summarize today histogram, including histogram equalize, histogram matching, how to compute by paper and pen, how to use ABI. Important. Because in final exam they ask you to compute paper with paper and pen. Right? To transform paper and pen, right? So you have to master the diagram from here. But in the exercise, you have to put conclusion. Conclusion again, the theory you know, right? And also ABI in Kirat and Python and Shiley. Now I give you about by default on the explanation here. Now I mainly depend on Kirat. Okay? How to use, right? Why the quantity linear, right? Become method. Why we solve the why we think why do we think that conclusion is linear? How to explain? And so on, right? That is, but the conclusion actually heavy on programming. So I will ask you to do some programming homework, right? Now 1 or 2 minutes. Any question more?
About fast Fourier transform. I mean, when are we using it?
Fast Fourier might be network. Okay, network is fast. You have net for also apply also convolution, but you also the convolution but net is for derivative đảo hàng, right? The meaning of that, and after that you go to the fast Fourier. You read at home before that.
Teacher. Can we have the slides used for convolution?
Okay, that is a slide for deep learning, right? And we upload.
Teacher, did the programming exercise appear live on PCAM? Because I don't see any exercise.
Sure, not right now.
Okay.
Not now. Okay. Slide we all upload. Exercise will be specified soon.
So we don't have exercises.
Not any programming exercise.
Programming and also the PKO.
Yeah, not now.
Not now.
Okay.